All right, everyone. Welcome to our final day of PostgreSQL and relational database management systems. Today, we're going to be, up to this point, we've covered how to create a brand new table. How do we go about deciding which sort of relationships we have within a table? As I mentioned yesterday, it is not uncommon for the majority of work that you do in the professional world to receive an already built database or receive an already built project. So it's important that we talk about how we should pick up these new projects and how we should familiarize ourselves before we start writing any sort of code and end up breaking things. All right. So we're going to start off our lecture by familiarizing ourselves with a brand new database, the best practices and pitfalls. All right, so a good practice here is going to be to make sure that there are comments on schemas. Here we have an example code of how to add a comment on a schema, which we'll cover here shortly. And we'll see how to grab comments out of that schema design as well within PostgreSQL. It is not as simple as just leaving a comment inside of the script in itself, because the script is not always going to be shared with everybody, right? What could happen is just the table gets uploaded, and once the table gets uploaded, it's uploaded in some sort of cloud framework, and that's where the table lives, but the script itself lives in someone else's machine, or maybe you guys have some sort of way to keep track of each individual script that was written before. Either way, the comments are not going to be living as to what we're used to, where we're writing comments strictly in the code. The comments will actually live within the database in itself. And we'll get a quick look at what that looks like here shortly. Now, why is commenting important? Again, like anything in code, you want to make sure that you're as descriptive as possible with your naming conventions, and you want to make sure that you leave comments behind to explain everybody or anybody else who picks up the project, hey, this exists for a purpose. It may not look like it has a purpose because it's just a table with two separate fields in it, but it does have a purpose. And if you delete this table, the whole project is going to crash. Do not delete this table, right? Because especially when it comes to data, we don't want just random tables existing in there. We definitely don't want extra space being occupied, as you'll learn whenever you go to deploy your projects. Your database is actually running the entire time, so it's eating up performance inside of your cloud server. So therefore, the more miscellaneous data that you have in there, or the more miscellaneous tables that you have, the more costly your database management system is going to become. So you need to ensure that you only have exactly what you need up on your server, and that there's a description to specify why it's needed. Otherwise, a senior developer or a junior developer might just have the fantastic idea of deleting that table. All right. So now, today we're going to go in depth into how to query databases. Here it gives us a very simple example, a select all from a table. When you go to query databases, don't just think about, don't just query to see what kind of data is in there or what types are being accepted inside of each field. Start thinking about connections and relationships, which that kind of falls into the next point here, right? The moment you start seeing some sort of pattern as to how it's being connected to other IDs, and you're starting to see relationships, bust out either TL draw or a Scala draw, or if you want to do draw SQL, bust out some sort of drawing framework, even if it's just a pen and paper, and draw out your database. Draw it out to where you can actually understand what fields you're working with, how the relationships look, and you could have a visual connection. Even if you're not a visual person, doing a drawing of your database will help you understand these relationships much better than just trying to read it strictly from the database. Also, it's just helpful to have a map that you can look at whenever you're trying to write a query, rather than trying to check each table to ensure that you're writing the correct query itself. All right, I've covered a couple of points here. I understand we haven't gone into practice, but does anyone have any questions over these points so far? All right, I don't see any questions, so let's moving on into ensuring data integrity. So in data integrity, we just want to make sure that here's where we're going to talk about where things should be not null, right? So typically things that should be allowed to be not, that should be allowed to be nullable are things that would not be vital to the program, right? So for example, if I'm writing something like a student registry, well, I probably need to know the student's first name and last name at the very minimum, but their middle name or middle initial may not be a requirement, right? So that's something that could be allowed to be nullable, right? When we talk about a student ID matching to a student, well, that's something that's definitely not null. So we need to make sure that we think about our fields, think about what is essential to the program, what information I truly need, and ensure that I set that to null. Now, again, this is actually something that you're going to have to think about when it comes to your application itself, um, because you don't want to overflow your database with unnecessary information. So if it's not necessary and it's nice to have, make sure that it is a knowable field so that you don't occupy extra memory space in your database. And then there's monitoring performance. Well, how do we monitor performance? We've been talking about, when we talked about creating some databases, we talked about some common practices as to how we should go about creating databases. And one of those common practices that we placed there was to go ahead and add indexes. And we talked about those indexes quickly and explained how they are meant to improve our performance within our SQL database. But we haven't seen an index being applied or how it actually works. We'll be seeing that today with this new command called explain analyze. All right. Now we're about to put all these concepts into practice. So I quickly wanted to run over them and have an overview before going into them. Does anyone have any questions about this so far? Okay, great. So if there aren't any questions for me, this is currently the new database that we are working with. It is a database that we haven't seen before. It is meant for a car shop. We can see that here we're dropping a department, some employees, a driver that's meant to have some sort of reference because I can see the cascade keyword there. That reference is coming from a car. And it looks like it's a foreign key relationship. So in this case, many cars can only belong to one driver. We have our plate, which our plate has a plate number or ID. And currently it's saying that we have a foreign key relationship, which is again a many to one. So we might have to even fix this relationship here of this plate. And finally, we have this car service, which looks like it's a many-to-many relationship here between a service ID and a car. Where is our service table? So here's our service table all the way up here as well. We can see that we have quite a bit of check constraints. But before I even start trying to do any sort of querying, the first thing I want to do is I want to actually draw out each one of these tables so I can see them. All right, so let's say I start off with my department store here. So I'm going to go ahead and say, excuse me, departments. I know that this is supposed to have a department name. And this department name is supposed to be unique and not nullable. So here we can see the question mark nullable. It is not nullable, but it is a unique key on the department name. And it looks like the varchar is actually 50. So let's set that type there of varchar of 50. All right, so I've created my department successfully. The next thing I'm going to create is my employees. Does anybody want to help me with building this employees table here? All right, let's hear it, Chris.
First, okay, you already got the ID. Cool. Salary will be the decimal type.
All right,
Uh, with 7 and 2.
okay.
All right, and then there'll be first name.
What about all these constraints?
Oh, sorry. How would you add? No, not null. So, yeah, how would I don't know how to add the not null checks. How would you?
Yeah, so the not null is already placed in there, right?
Okay,
We have a couple of other things here that we can add, such as primary key, unique, or index. But
okay.
typically when you want to add these checks here, you can
hmm
go into the comment section and say check salary is greater than 0.
And then when you hover over it, it'll show up or something.
Yeah, so now when I click on it, it tells me
Uh,
check salaries greater than 0.
gotcha. Cool. All
Awesome.
right. And then first name will be varchar type with a parameter of 50. And then the not null.
Right?
It does it automatically do not null?
It does, yes. The only time it identifies nullable if it's like click on it.
Gotcha. And then the middle int char1. And then department ID int. And then the foreign key. So we don't have to do anything for the last two things, do we?
Oh, we do actually. So this department key is saying that it has a reference to department ID.
So that'll
So
be okay, got you. For yeah, to the department there. Got you. And then for middle, the length is 1. So it'll be another. So do we make a comment with middle int? Yeah.
yeah, what I want to check.
Check is null or length is 1.
All right.
Cool.
Awesome. So there you go. And this connection here between employees and department, is that a one-to-one connection or a many-to-one connection?
It is for department to employees. I think you can have multiple. Yeah, you can have. Should it be many to many? You can have many departments with many employees.
Well, for this specific example that we have
Okay.
right in front of us, right? What do
Okay.
you see? Do you see a many-to-many relationship, a one-to-one, or a many-to-one?
I think I just see 1 to 1.
Okay.
Mm-hmm.
Um, so I see here that we have our reference, right?
Mm-hmm.
And because it's a relationship strictly to another table, it tells me that it is not a many-to-many relationship, right?
Right.
Otherwise, we would have a connecting table. Now, you said that it was a one-to-one. What is enforcing that an employee will not have a duplicate department ID?
The foreign key. Well, so in department, there's no references of employee, so ah, I'm getting confused. So
Yeah,
meaning to 1, I guess, since department is only being referenced from employee and department is don't have any references to employees.
right. If employees had a unique keyword here in department ID, then we
Mhm.
would be able to identify that as a
One to one.
one-to-one.
Yeah,
But because it is not unique, it is a many-to-one relationship.
2 1. Gotcha. Okay.
Awesome. All right. Thank you, Chris. All right. I see a question from Brandon. Go ahead.
Why is the check for middle in it not attached to middle in it and at the end?
It's just different conventions. Sometimes you could put your checks right. It's up to you where you want to place your checks. You could place them right next to the independent field, which is what I do. I typically put the checks next to the independent field, or I just indent it. Some people, when it becomes too large, rather than indenting it and just doing a small space, they just save all their checks and they place them at the bottom of that table. And then the checks could be divided by commas. Does that answer
I
your
was just
question, Bear?
confused. I was just confused because one for salary they do put the check next to it, but for middle in it they don't. So it doesn't really seem standardized.
Right. So there's a problem there, right? We want to make sure we're following a pattern, and they're definitely not. So they are doing it in a preference space where, oh, if it's small enough that I could write in one line, I'll just put it in there. But if it's something too big to where I have to indent it, then I'm just going to save it till the end. Not necessarily what we want. We either want to have it right next to the individual entity field or all checks at the bottom. Len?
Okay.
Yeah, so with that question, I'm just wondering, so I was thinking about this yesterday, is there any kind of like order requirement for putting in the tables? And I think you might have mentioned it before, but I just want to like explicitly ask the question, like if there's a dependency or something like that, or if you're creating tables that are going to be linked, is there an order, or can literally anything be changed as long as all of the stuff for one table is under the create table?
Got it. Yeah, that's a great question. So if you're creating dependencies, and I think it's the only real time where there should be an order as to your creation goes. The table that you're going to be creating a dependency on needs to be created first. So in this example, we have department and employees. Well, the dependency is going to be on department. So I need to create the table of departments first before creating my employee table. There is a different way to do it to where you can spin them and then just run an alter table, but you shouldn't put that into common practice. You should only utilize that when you're working with an existing database and you're trying to add a connection.
That makes sense.
Okay.
Is the cascade there on department like the clue to the developer to say, hey, this is dependent on something and it's far, it's coming up next or it's down below? Is that like a clue, or should I just ignore that and it's more of a?
I wouldn't call this necessarily a clue. I think once you map things out, because you're not always going to have access to the create schema, once you map things out, you'll see the different dependencies. And then from there, you'll realize which tables come first.
Got it. Thank you.
Of course. All right. So moving on to services. I'm going to go ahead and do services since that's a smaller table. I'm going to add services here. We already have our integer. We can see that we have our name of service as well being added, which is a varchar of 100. We can see that this is not a nullable field. It should be unique. All right, there's no other constraints on there. And finally, we should have a price, which should be a decimal field with a 7 and 2 as far as to the prices. It should not be nullable. And we should have a check ensuring that price is greater or equal to 0. All right, so there's my service table. I now have my service table built out. Can somebody walk me through creating this driver table? All right, let's hear it, Raven.
All right, so we got the ID down. We're gonna put down name with varchar with 100 characters.
Right.
and that one's not null. And
Got it.
then take down the phone. Varchar with 15 characters,
Okay.
and then email and varchar with 100.
For phone, is that something required? Is that nullable or is it not nullable?
We should probably take that down so we can put not null inside of our create table.
We could, but right now we're trying to just replicate this. So we're actually gonna mark in our drawing here, hey, this is gonna be a nullable field.
Gotcha. Okay.
All right, and then you mentioned email should also be a varchar of 100 characters. Okay, what else?
And that one's nullable as well.
All right, also nullable.
And age will have an int. And we're gonna make a comment with checking age is greater than or equal to 0.
All right. So there you go. We have our comment built out. I'm also seeing here in integer that we don't specify that it's not nullable, so this should be a nullable field as well. So it looks like we really don't care much about driver details other than their name. All right, awesome. So there you go. We have our driver. The next thing we have is the car. Does anybody want to help me out with building this car table? Let's hear it, Tim.
So, looks like you already have your ID, so make varchar 50. And then do the same thing for model below it for another column.
Right, so model. All right.
I'm a little confused about how this year is set up. It wants to check to see if it's more than 1500, but I don't think that matters for the table, correct?
So it looks like it's an integer type, right?
Yes.
Make sure that it's not null and it has
Yep.
a
And then
check. Go ahead.
if it's more than 1900.
Yeah. So let's go ahead and implement that check in there. So,
So you added as a comment. Okay. I was
right,
curious of how you did that.
check year is greater than or equal to 1900.
Okay.
All right. Awesome.
And then color with varchar 20.
Okay.
Driver. I'm not sure why that's int. Shouldn't it be a name?
Oh, let's try to think about this, right? So currently we have our driver here for a car. And so let's connect these two, right? It's saying, hey, my driver. Oh, excuse me, I may need to open this up a bit. It says, hey, my car has a connection to a driver. Well, how do I build this connection? Is it possible for multiple drivers to have the same name?
Yes. Not the same number. I understand now.
Right. So if it's possible for them to have the same name, I can't build the connection depending on a name, right?
Why is it only int in the SQL code that you're building and big int for driver in your tables?
Oh, let me change that here. I need to change that to integer. Thank you.
Okay.
Yeah. So what we're doing here is we're making a connection between the driver
Mhm.
to their ID.
Can you show the foreign key now?
Yeah, absolutely. Let's go ahead and take a look at the foreign key reference there.
So now you want, okay, so you're referencing driver ID.
Right. So I'm
Okay.
connecting that driver to the driver ID. And what sort of relationship is this? Is this a
Well,
many to
since there can
many?
be multiple drivers, I would say it's many to one.
Great. Yeah. So multiple cars can belong to one driver, right? Because that's the way we have this set up down here.
I
We
was
have it.
thinking multiple drivers can drive one car, but so it could be many to many then.
Yeah, it could definitely be a many to many relationship. But it looks like the way the shop has it set up is to where every car that gets registered can only belong to one driver. So maybe they
Oh,
have it in a system to where the same person that drops off the vehicle has to be the same person that
mhm.
picks it up, right?
I see. This is like a service center kind of
Right.
thing.
Yeah. So let's
Okay,
go
thank
ahead
you.
and, of course, no, thank you. And then there we go. We have our many to one relationship. All right, Chris, let's hear it.
What's the big difference between int and then big int?
So integer handles a number from a specific range, but big integer handles every number all the way up to, whatever number that PostgreSQL is possible is capable of actually handling, whereas
Gotcha.
integer does not go up that high.
So for ID, I mean, there could be unlimited IDs for driver. Should it be, or yeah, should it be big int, I guess?
That's a good question, right? If our ID serial numbers is already coming in as a big int, then why
Right.
would we place in the driver itself as an integer, right? And not make it a big int? So that's a good question. We could definitely make that change. Let me make sure that I could do that here. And we could have
Oh, so
it
you
to be
also
a big int.
Oh, so it has to specify. I thought that was only a table thing. So you have to say it in the code as well, big int.
Right, you would have to specify it in the code. Yeah, if you
This is
wanted to
sort
make
of
it
what I
big.
was asking earlier. Thanks, Chris. You really made it easier to understand.
Gotcha. But I don't think there's any big ints in the code. So do we need to change all the big ints that we wrote?
We could, right? That's not necessarily what we're aiming for here. What we're aiming
Okay.
for is replicating the tables, but you definitely can.
Gotcha.
All right. Momo?
Yeah, I'm sorry. One more time. Why is not many to many? How did you know that many driver can drive the same car from the scheme here?
Yeah, so if I take a look at the schema here, I have my driver and I have my car class, and I can see that I have a connection happening from the driver, and the reference is directly to the driver table, right? So we learned yesterday that if I were to do a many-to-many relationship, I would have a connecting table. So because I don't have a connecting table, it already tells me that the only two possible relationships that I have here
Okay, I
is
got
a
you.
one-to-one or a many-to-one, right?
Okay. So as long as there is no connecting table, okay. So yeah, okay, I got it. Thank you.
Right? Oh, okay. And then just to specify, the reason why this isn't a one-to-one connection there is because driver is just an integer and it's not specified to be unique. So that means we could have multiple cars that have the same driver integer ID. All right. Okay, awesome. So moving on to the plate here. Let's go ahead and do our plate. And this part I don't necessarily agree with, right? As we saw, there are some other parts in the schema that we may or may not agree with, but they could have the schema built out this way for a specific reason. So maybe as I'm going through the schema, as I'm writing it out and I'm seeing these connections, maybe I have these questions like, hey, why do we not have a many-to-many relationship with drivers and cars? Like, do we have a system to where the same person that drops off the car is the only person that can pick it up? I also noticed that all of the contact information for a driver is nullable. I would assume that that's something that we want to keep track of. Why do we have that as nullable? And maybe there's a specific reason why they have that information, right? Maybe some people, when they drop off their cars, they don't leave and they're going to be staying. And because they're staying within the vicinity, all we care about is their name. Who knows why they have it built out their way. But as I'm familiarizing myself with this database, I'm writing down all of these questions so that I could go to the next level up or whoever's in charge of me and say, hey, why is X, Y, and Z happening before I start writing any sort of code? I want to make sure that I understand the database. And Erica, I saw your hand up.
No, I was just gonna ask, you just clarified it, we would have to ask, because it's like, not just assume it's correct and be like, hey, this doesn't seem correct to me. Is
Right.
that okay? Yeah.
Yeah, definitely. It's definitely okay to ask. And those, whenever you go ask a question to people, to the people above or someone above you, make sure that the question is, directed, right? So if somebody tasks you, hey, get familiarized with this new database, here's what we currently have, map it out, get yourself familiarized. And rather than going through the entire database, writing down your questions, you continuously go up to that individual and ask each question as you come up with it. It's going to become time consuming. That individual may get frustrated. They may become unwilling to answer said questions. It's better to just compile an entire list, have all of the questions that you want to ask all at once, so that when you show up, you can say, hey, can I borrow you for 10 minutes? I have a series of questions. I went through the database. I want to make sure that I fully understand it before I start writing any code. Tim?
So when it's not null, it has a question mark on it. Does that mean that that data does not need to be present? Or am I confusing that with it has to be there?
Yeah, so when it has a question mark, it means that data does not have to be there, and that means it
Okay.
is nullable. So
Okay.
these 3 fields are nullable. Excuse me,
That's what I thought.
nullable
I was
fields.
just making sure. The visual really helps me, so thank you.
Of course. All right, so let's start writing down this plate now. So moving on to my new table, I have a plate. This plate has a plate number, which seems to be a varchar. And it's weird because in this case, we have plate numbers, but from what I'm tracking, usually places utilize VINs, but maybe this place needs a plate number for a specific reason. This is not nullable, so it needs to have that input. And every time that it's placed into a database, it needs to be unique. All right, and then finally, we have an attachment to a car ID here, which again is specified as an integer. Doesn't seem like it has any nullable information, but it does have a connection. All right, again, this connection, if I look at the reference, it's referencing directly to the car table. So because it's referencing directly to the car table, I know it's not a many-to-many relationship. I can see that the car ID is not unique. So that tells me that what I'm working with here is a many-to-one relationship. All right, so there's my schema so far. I have my car connected to a driver, where a car can have many plates, a driver can have many cars. Tim?
I apologize for asking so many questions, but when car ID, you put it as int for data type, wouldn't there be many cars and you'd want to use big int? Is there any particular reason used in that situation?
No, that's a great question. Currently, the only reason why I'm putting in int into the table is because that's what's being provided to me by the schema. Right? This
Okay.
is what was provided. That would be one of those questions that I would write down. And when I go up to that individual to say, hey, why is this the way it is? That's one important question that I would ask there. Hey, if our car grows, are we going to move on into big int? And maybe their answer is, hey, we're waiting until we have enough records to change it to try to keep our prices low in cost as far as how much performance we're utilizing at the database. And then once that happens, they could alter the field to turn into a big integer field.
Makes a lot of sense. Thank you.
Of course. Chris?
Yeah, I was just curious. Yeah, we can always adjust this with big int or small int or whatever else. Regardless if we are done with whatever. For future reference, we can always go back and change it. So okay, I was
Right.
curious would have messed anything up if we do that, but I guess not.
Yeah, as long as it matches, right? So if you have an integer field and it's able to be parsed into a big integer, then there's not a problem, right? If you try to go backwards, like try to turn it from a big integer to a small integer, and it's outside of its capacity, then it will
Mhm.
throw an error. It'll say, hey, we can't do this. You have data in there that's already conflicting with this constraint.
Gotcha. Thank you.
Yeah. All right. And now we have our final table here, which is our car services. Can somebody walk me through creating this car services table? All right, Tim, let's hear it.
I'll do it again. Um, so service I underscore ID, make it int. Spelled it wrong.
Oh,
Cool. Next column is car ID int, according to what it wants.
all right. So car ID, which is going to be an integer. All right.
And that's it. Now we make the connections.
All right. So let's take a look here. We have our services, which are an independent field that fall within cars. Okay. Now, what sort of connection is this going to be?
Are you asking me or are you asking anyone?
We could go with anyone. Let's see. Let me call on somebody to get some more input here. Let's see, Dustin, what kind of connection we have between car services and services?
Car services and services. So service ID and then references the services ID, right? So yes, so service ID up on top
Mhm.
or there, yeah, would connect to the car service ID or service
Okay.
ID, right? Right.
Okay, awesome. And would this be a one-to-one relationship or a many-to-one relationship?
So, the car service has a unique ID, right? Um,
Um, it seems like service ID and car ID, neither of those are unique.
uh, so the many to many or many to one.
All right.
Yeah, many to
So
one. One
between
to
these
many.
two tables, we would have a many-to-one. Awesome. All right. Garrett, what about between car services and car?
Would it be the same thing? Would it be one to many?
Nice. So we would have a many-to-one as well. Okay. Well, this is great. So we have a couple of different relationships here. We have a many-to-one relationship between my departments and my employees. So it looks like my employees can only serve under one department at a time. I also have drivers, which it looks like all vehicles can only be dropped off and picked up by one driver. I have a plate, which it looks like multiple plates can belong to one car. Maybe we're in like a state border and we see the same car coming over again with different plates from different sides of the state. Who knows? Um, and then we have a many-to-many relationship between services and car. And we know we have a many-to-many relationship because we have a connecting table here named car services. All right. Awesome. So now we just successfully mapped out our data of what we currently have. Now, let's say I didn't have this database schema, right? Well, if I didn't have this database schema, what I would have done, and give me a second here, Tim. What I would have done is I would have gone to the database itself, conduct a \D, and from there, I would have started from top to bottom. All right, I could have gone from the car down to car services, mapped each individual one out, and from there, I would have been able to see each one of the connections and what they were meant for. All right, Tim?
Why is department employees not connected to anything else?
Yeah, so department employees is not connected to anything else, right? Maybe in this database, I don't need to know who conducted the service. Maybe I don't care who conducted the service, right? And all I need to know about my employees is separate about my actual service that's being done to my vehicles, right? So these are two separate sections here. One is taking care of the vehicles, and the other section is taking care of my actual in-house stuff, which are the separate departments that I have. Maybe I have something like a technical department, or we have wheels, oil changes, the tires and oil changes, service departments, etc. Right? And each employee falls into a specific department, and that's all I need to manage in the database. Everything that I need to manage regarding my car, the vehicles that are being brought in by drivers, and the services that I'm providing is in a separate section, right? These two you don't always have to have connections between everything. You could just have a separation as long as it's being managed correctly. Does that make sense, Tim?
Yeah, so this is a common practice to have like multiple, so you have your department for employees. I get it. And then you have your driver for his car for when he's bringing it in, for example. They don't need to be connected, as you said, but is it common practice to put it in the same schema design? Or would you make separate designs for that most of the time?
Yeah, so if I'm making an application for a car shop, right? And this car shop needs to be able to, let's say it's like the manager that's utilizing this application, right? Well, this manager not only needs to be able to manage the services up in the front, he also needs to be able to manage the employees and departments that he currently has, right? And then maybe we have a conditional in there saying, hey, if this person is a manager, or if this person has manager permissions, they can see and interact with these two tables through our API, right? But if they don't have manager permissions and they're just the person at the register, well, then they only have permissions to communicate with the car section of our application.
Makes a lot of sense. Thank you so much.
Of course. Chris?
Do we, for employees in our SQL, do we have a label called last name, or is this only stop with middle name?
Oh, that's a good question. Maybe we missed that. Let me check here. We definitely have a label name last name, and I might have just missed that. So let me go ahead and add that there. Good catch. Thank you, Chris.
Well, it was Raven that said something in the chat, but
oh, nice.
Give him the credit.
All right, let's see. This was a varchar 50. It is not nullable, and it doesn't have any checks. Okay, great. All right, Dustin.
I understand it works for this, but if we had a many-to-many, would we want the IDs more like specifically labeled?
More specifically labeled.
For like that, because if we had a many-to-many, we would have that join table, right? And we would just have ID and ID in there.
Well, in this join table, we would name it service ID and car ID. The only time that ID would actually be registered is within the car table itself. But you're definitely right. Typically, I don't want to say always, but I strongly recommend that when you create a table, you do something like car underscore ID, because it can become extremely confusing if everything is just .id and you're working with multiple tables and you're trying to run maybe a series of join queries. You need to make sure that you're specifying the different types of IDs. We'll see how convoluted that can get in join tables here shortly. Does that answer your
Got it.
question,
Okay.
Dustin?
Yes, yeah, thank you.
Of course. Joseph?
So you said that if you didn't have the schema, that you would have just ran the \d command, and then you can see the tables from there. But where do you see the relationships between the tables? Is that what the sequence is?
Yeah, that's a great question. So our sequence is not taking care of the relationships. If we recall, the sequence is taking care of every time there is an entry. The next entry will be 11, then 12, 13. It's making sure that it's escalating, right? And that table is being created from our serial primary key. That's what creates this sequence table. But how do I see those relationships, right? Let's go ahead and run select all from car. And I believe car does have a couple of dependencies, or at least one dependency, right? So when I run this information here, I wouldn't be able to see if it's a one-to-many relationship or a many-to-one relationship right off the bat, right? So how do I ensure that I'm actually able to grab that information, or that a new developer is able to grab that information? They'll see the driver, right? And from seeing driver, when we go into drawing the driver table, we can put it together and say, oh, well, a car has a connection to a driver. But how do I make sure that I can see this connection, right? That I can ensure that I have a many-to-many connection. Again, I don't have access to the schema itself. So how can I do that? Well, what we're going to do now, and this is going to take me into our next portion, is how do we add comments into our table, right? So let me go ahead and uncomment all of this information here, right? Currently, I don't have any comments. And because I don't have any comments, it puts developers at a disadvantage, because just like Joseph, I think that was Joseph, I apologize. Yeah, it was Joseph. Just like Joseph mentioned, well, it tells me that there's a connection here, but I don't know if this is a one-to-one or a many-to-one. So me as a developer, whereas the person creating it, or at some point, someone should, and hopefully will, add a comment on a schema. And in this case, what we want to do, oh, and I apologize, this isn't schema, it should be table. And what we want to do is specify the table. So here we go. The table is car. And then I can say is. All right, well, what is the comment that I want to add? Car has a many to one relationship to a driver. All right, and that should add my schema there. All right, well, I'm adding a comment now. Let me go ahead and run that \I, make sure that I have all my information. Okay, so here we can see that Cascade was able to drop some relationships. We created some tables, we copied some information, created some tables. Again, drop Cascade, drop and create tables, drop Cascade, drop and create tables, drop Cascade one more time. And then we drop and create tables. And then there's this very specific part here. It says comment. So a comment has now been added into my database. Well, all right. Well, that's great. A comment has been added into my database. I would hopefully expect to see that rather easily, right? I can say, all right, well, select all from car. And when I go to select all from car, well, I do get all of the regular information, but I still don't get the comment. Well, that's because of where comments are being stored. So comments are being stored in a separate table called PG description. It's one of the hidden tables that's being created by PostgreSQL in the background. All right, we don't necessarily have direct access to it. It's kind of like how a .git file is being hidden from everybody, and every directory that starts with a dot gets hidden from you in the terminal. You don't necessarily see it unless you explicitly invoke it. And because of that, PostgreSQL has given us a very easy tool, or a function, I want to call it, method, to be able to grab what we have, or to be able to grab our comments. So in this case, what we're going to do is we're going to run a select statement of object description. This is going to grab descriptions of a specific object. The object that I want to grab from is car. Then I'm utilizing this reg class here. Now this reg class is a separate function. What this reg class does is it looks through all of the registered classes inside of the database, finds car, and returns the registration ID for car. That ID is utilized by the obj description to then find the descriptions connected to that ID. Now, that's a lot of the under the hood stuff. If you want to kind of data dump that for now, just so that you could listen to it later and maybe read about it, perfectly fine. No, this is the method that is going to return all of the comments attached to the car class, or excuse me, to the car table. Well, when I run this, I get, hey, here's the object descriptions. The car has a many-to-one relationship to a driver. Awesome. All right. Does anyone have questions regarding adding or viewing comments? Joseph, did that answer your question?
Yes, thank you.
Of course. All right. So now we just went over all of this information, but let's say that we want to run some sort of where clause, right? And we find ourselves often querying the database to check how many vehicles inside of our shop at a time are above a specific year, right? Maybe we want to create some sort of statistics about how often cars start breaking down, right? And maybe we're checking, hey, maybe 5 years ago is what we want to start checking for. Well, 5 years from now would be 2019. So I would run a where clause consistently where I say, hey, select all from cars. And we'll go further into what this where clause actually does. Where year is greater than or equal to 2019. Oh, hello. I totally messed that up. Let's go back to 2019. There you go. All right. Well, when I run this, it's going to give me my information, but I want to see a little bit more detail. All right. I want to see how efficient this actually is. Well, let's go and add this explain clause at the very beginning of that command, right? I'm still going to run my, hey, I want you to select all, but now I'm going to add an explain clause at the beginning. Let's see what happens when I run that. Well, when I run my explain clause tells me, hey, this is a sequence scan on car, meaning it's kind of like an iteration process, right? It's going from left to right. It's happening sequentially. The cost of it was 13. There was a total of 80 rows. It tells me the width, and then it tells me how much it filtered by. Okay. It gives me a little bit more information as to what's going on whenever I'm actually writing a query and the performance behind writing a query, right? Well, what if I want even more information? Well, I can add an extra argument called analyze. And when I run analyze, it still gives me the cost and it gives me the original stuff that I got from explain. But now in analyze, it's also telling me, hey, how many rows were removed by the filter? So we get here that only 3 rows were removed by the filter. And then it tells me it took me 80 seconds to plan this execution or to actually get ready to conduct this row, or 80 milliseconds. And this is how long it took for me to apply this execution, for me to come up with a result. And I see a question from Earljon. Go ahead.
Yes, so I see that the rows is 80 and then the width is 306, but the row does not really have 80. So what is the 80 pertaining to?
Yeah, that's a great question. So this row portion and this width, right? We can see that the width of the thing is not 380 fields, right? Or 306 fields. And we can also see that we don't actually have 80 rows. All right, so what is it actually coming down to? Well, and I may be wrong here, but what this is actually evaluating is strictly from left to right and top to bottom. All right. It's not actually following rows in itself or columns in itself. It's just going 1, 2, 3, 4, all the way across, analyzing the individual text. Again, I may be wrong, and I may have to look into that to give you a better answer. Does that answer your question, Arjun?
Yes, thank you.
Of course. All right. So now this is giving me some pretty good information, and I'm consistently going to be running this where clause on a year. Well, if I'm consistently running a where clause on some sort of entity field, I should add an index to set clause. So I'm going to go ahead and create that now. I'm going to say, hey, I want to, not only do I want to add that comment, I want to create an index. And what I'm going to call this index is IDX, because we know that this is an index on car year. And this is happening on the table car on the field year. And that is going to create my index. Well, let's run this \I command one more time to recreate our entire table. All right, so now I've not only created a comment, but I've also created an index on the car table. And let's take a look at our explain analyze as to what it was before. And let's see what happens when we run that select clause again with explain analyze. All right. So now, the first time we did it, where we did not have an index, the planning time took 80 milliseconds, right? Or 0.08 milliseconds. And then the execution time took 35. Well, now that we've added an index, the entire purpose of an index is to increase performance. Well, how does that happen? Well, we increase performance because I am now adding more into the planning time. It's taking a bit longer to plan how it's going to find this specific query or execute this command, right? And I'm seeing that we have our actual time here. So we have 17 seconds. It had row 7 and 1 loop. Here it took 9 seconds. Still had 7 rows and 1 loop. And look at the planning time, right? The planning time is 114 down below. When we did have an index, the planning time was 80. So the planning time, definitely we lost out on, right? It's taking longer for it to plan the execution, but the execution is faster, right? It took 24 milliseconds to do the execution. And up here, it took 35. Now, this may not seem like a huge difference. And you may think to yourself, oh, well, if I'm losing that much time in planning time, then we might be better off without having an index. But keep in mind that what we're working here is we're working with a table that currently only has 10 records. If this table had thousands of records or hundreds of records even, we want to ensure that we sacrifice that bit of planning time so that our execution time can become a lot faster. And that's how we conduct indexes in PostgreSQL. Does anyone have any questions in regarding to indexes and checking for performance? Let's hear it, Chris.
What was the command to run it like that, or to see the planning time and the execution time?
You add explain analyze at the beginning of your select statement.
Gotcha. Okay, I see it. Thank you.
Of course. Any other questions? All right, it doesn't seem like there are any questions. I'm going to go ahead and stop our recording here. All right, welcome back, everyone. We spent the first portion of our lecture getting familiarized with this database. We actually drew it out in DrawSQL. We went through the process of adding some comments to ensure that we can actually understand what's going on here. And we even created an index to allow for some performance improvement within our query statements in our database. But now we're going to go into actually writing some queries from this data. Now our data isn't very complicated. As you can see, our car services, which is a connecting table, is just a series of IDs. Our car has our car connected to a driver. We have our departments, which are, placed in there as well. We have the driver in itself with some information, even though it's nullable, it looks like we have all the information for drivers. Here we have some of our employee information along with their salary. Here are the plates for each individual car. And we have our services for what that our shop actually offers. All right. So nothing too crazy. But sometimes when you're working within SQL, the most common task that you'll get is generating reports. When you generate a report for some sort of organization, it's essentially a series of queries, right? We want to grab information from the database in some specific format, letting the organization or the business know how they're doing in specific areas. So today what we're going to be covering is how to conduct these queries, right? So we're going to start with the very simple stuff. The first things that we'll start off with is our where clause. Our where clause, as we saw earlier, it opens up an if statement, right? So let me go ahead and add that in here. So where opens an if statement. All right, so when I run a query saying select all from car, I can say where. So there's my if statement. And just like we saw earlier, I can ask if the year is greater than 2020. Right? So there's my select clause. I can execute this here. So I can run \i queries.sql. All right, when I run it through queries, we get back our table of 3 individual rows with Chevy, Mercedes, and a Jeep. So that's our where clause. We could do greater than. We could do greater than or equals. Which in this case, it may not apply. Let's do, actually, let's go ahead and try it. Maybe we do have one. Oh, we do have a couple. Look at that. We have 2 additional vehicles that were now added. And we can also do a less than clause. Anything less than 2020 can also be applied. All right, so all of our usual math operands are still there. This is the same thing as saying if year, or let's say we were talking about OP, right? Let's say this was car.year is less than 2020, right? And we were running a filter function. So let's say cars or filter. I'm not sure what we're used to here. And we do cars where our lambda function is being instantiated. And I say where car.year is less than 2020. All right, that's what we're actually running here. We're filtering all of the entry of our cars to meet our specific condition of car being less than 2020. All right. This is Python code in case anybody was anybody's curious as to what syntax I'm utilizing here. All right. Any questions in regards to our where statement and our mathematical operands there? Go ahead, Dustin.
I'm just wondering, you can only query what information is in there, right? Like, so you couldn't current year minus 5 years, right? It doesn't, unless it knew what the current year is.
There may be a way to grab the current year. Let's see that. Let's see
Like
PostgreSQL.
Are you able to import things into SQL, like database or like a file?
You don't actually import things. It looks like there is a function there to grab the date and time. So it looks like you could grab, use the local time of now. Let's see what now returns here. I don't know how this operation is going to work, but let's see if this will happen. If it doesn't, I apologize, but I'm going to have to disregard this question. I may have to figure out how it works, but it looks like there's a now operand. I'm sure there's some sort of logic that we can write to actually get that, like from now previous to 5 years. I just don't know it off the top of my head.
Right. Yeah, that's fine. I was just, yeah, how it implies to other things too. But I appreciate it. Thank you.
Of course. All right. Now, moving on to the next thing that we have here is, I call this mathematical operands, but so far we're just doing our comparisons, right? Well, how do I actually run some operations of these things, right? Let's say I want to have a count of all the cars that I currently have in the shop. Well, rather than just running select, I can say, hey, I want the count of all from cars. And by running this query, you'll see that I get something called count of 10. Right? So I currently have 10 records of cars that are living within the shop. All right. So now let's say that I wanted to see or identify cars that have some sort of value in them, right? And let's take a look at our cars database here. So it doesn't look like it gives us all of our data, but what we can look for is cars that match a specific color, right? Maybe maybe we have a service for shop work and we're running out of a specific color. So I want to know if we have enough color to cover the cars that we have in the shop waiting to be serviced, right? Where I can say where color is red. Right, if I take a look at my CSV file, that is what I have for color. And if I run this comparison, it looks like is red isn't working. Let me see here. Syntax error on or near. It might be because of this is. It may be that I just need this equals. There you go. So now I know that I have 2 vehicles that are of the color red, right? And if I take off this count operation there and I run it, we can also see that it comes back correctly. Brandon, I see you have a question.
Yeah, I noticed that the syntax error inside of the count statement actually added double quotes to the single quotes, and I wonder if removing the single quotes on line 4 would allow us to run that count.
So you're saying to do is and then do the single quotes?
Remove the single quotes. Because it looks like on line, just above line 1 in the terminal, where it says line 1, select from where is red.
Mhm.
It says at or near quotes and then single quotes red. Do you see that?
I do, yes. Let's go ahead and try it out. So we see
Okay,
that we
yeah.
still get the issue and there's still double quotes being added. This double quotes is just letting me know, hey, this is the input that I received, right? So that's why we see I received an input, those the double quotes, and this is what the input was.
Okay, gotcha.
All right. So go ahead and revert that back here. Okay, so there you go. We're able to get a count of something. Well, if we're able to get a count of information, that should also tell me that I'm likely able to grab the sum of some things, right? So currently in my services, what I have here, right? Let's say that I wanted to see, well, depending on the services that I'm conducting on that day, or maybe I just want to see what would happen if a car received all 3 services, right? Well, I can use the sum operand to grab this information straight from my database. And I could do that by saying select sum of price from car, or excuse me, from services. And let me ensure that that is in fact what we named our database here. \d. It looks like we named it. Yep, we named it services. So I can say, hey, I want to grab the sum of services. And there you go. If somebody were to come into the shop and say, hey, I want to get all 3 of the services that you have to offer, they would have to end up paying a total of $129.97. Right? So that's our sum operand. Now, another thing that's really useful is, well, what's our average, right? Or what is the average thing of something? Let's say we're trying to post a job posting and we just put it as in a general person that wants to work for our store. And we have to put what the average salary is for our shop, right? Well, we can go over to our employees table. There I see that there is a salary. So I can say, hey, well, if what I want to do is grab the average salary, I can say select average salary, and then say from employees. And when I run this query, we can see that the average salary for my employees is $55,000 a year. Right. All right. And notice how in our employees table, we do have it set to a decimal point that's only set to 2. But when we do this average, it continues going past 2. So just keep that in mind, right? You may need some additional formatting whenever you run a SQL query like that. All right. So there you go. We've covered average. We've covered the where clause, the sum, and count, along with our mathematical comparisons of greater than, less than, and greater than or equals, equals, and less than or equals. Does anyone have any questions over those different types of operands and conditionals up to this point? Chris?
Yeah, if we did set the decimal to only 2 decimal places, why is it returning multiple zeros or?
Yeah, that's a great question. So we set the decimal to 2 decimal places as to what is going inside of our database, right?
Mhm.
But this isn't coming straight out of our database, nor is it going into our database. So it doesn't have that limitation of 2 decimals. So instead, what it's trying to do is it's trying to be as accurate as possible. So if I have some sort of other number, I believe this is going to be a total of 16 decimals. I'm not going to count it off the top of my head. But typically this would account for up to 16 decimal places. And then after that, it would start to lose accuracy. So that's the reason why it has this many decimals. Does that answer
Gotcha.
your question?
Yes, sir. Thank you.
Of course. All right. So now we've covered a little bit of our where clauses, but we haven't talked about the complicated stuff of our where clauses, right? Like when we're working with string, what kind of things is it that we can do with string whenever we're trying to run some sort of SQL query? Well, there's a couple of string operations. You could actually do string manipulation within SQL. We're not going to be covering that today, but know that that is a capability that you can look into. Instead, what we're going to go into is how to query from the database depending on some sort of string pattern. And by string pattern, I'm not referencing regex. I'm actually referencing the starting with, or if it at some point in that string, this information is located, right? So if I take a look at my car, in my car, I see that I have my make and models there, right? Well, what if I wanted to grab all of my cars that were of type Honda, right? I want to make sure that I grab all the cars with the make Honda. I would say select all from car where make is equal to and Honda. Well, look at that. I run my query. I only get back one vehicle. It looks like we only have one Honda Accord in stock. And that's great. Well, what if I wanted to see something a little bit more difficult than just Honda, right? What if I go, let's go ahead and go into our drivers here. And what if I wanted to see all of our drivers who have a specific last name, right? Maybe I'm looking for the first name or last name of Johnson, or yeah, let's start off with Johnson, right? Someone comes into the shop, they say, hey, I don't have my information. My last name is Johnson. This is the car I'm looking for. And I want to confirm that they exist within my database. Well, I can run my query here, say select all from drivers. And let me ensure that that is what we called the database. We did call it driver. And then I can say where last name this isn't just the last name. It looks like we just account for name. So I can say where name. Well, if I do where name is equal to Johnson, this is going to return an error. Right? It's going to say not necessarily an error, but it's going to return 0 rows. Well, how do I specify that I want to grab anywhere where the string pattern lives towards the end of that parameter? Well, I would put an ampersand. And by playing an ampersand in there, what I'm trying to say is, excuse me, not an ampersand, a percentage sign. What I'm saying in there is that I am looking for the string of Johnson being the last values. So it would match in reverse, starting from N all the way forward to Johnson. And wherever it finds that being matched, it would actually run that information and return it in our query. So now if I run this query, looks like this failed. Did I misspell Johnson? Daniel, you have a question or a suggestion?
I think you forgot a semicolon.
Aha, that might do it. Oh, that still didn't do it. Select from driver. Let me see. Well, we definitely have Johnson in there. Let's see. Go ahead, Arjan.
In the select in line 12, I think you put the asterisk instead of select name from driver, where name equals to Johnson.
No, that should still work. There's something else going on here. I just need to figure out. Oh, there you go. Yeah, thank you. Appreciate it. Rachel for the win. We're gonna use a different type of comparison here. Rather than utilizing an equal sign, because it's not gonna be a direct match, what we want to utilize is a like statement. Hey, I want this to be like such, right? And when I run this \I, then it's able to match backwards from Johnson, right? Another useful way that we could do this is maybe I want to grab all who utilize a specific email, right? Well, I can say select all from driver. And I think in this case, all of them use example.com. So this might be a weird example, but we could see it at least. Where email like, and then we could specify at example.com with our ampersand there. And if we run our \I, it would return all of our users who have example.com. Chris?
You just answered my question. I was wondering, would it bring up all the similar name, like if it was another name with Johnson or whatever? So it would. So cool. Thank you.
Of course. Yeah. And now we could do it with the starting information, right? Doesn't seem like we have any duplicates there. Let me see if we have any duplicates inside of our employees. Well, we have some people who do start with the first letter in employees. So let's do that. All right. I want to grab employees by their initial. I can say select all from employees where first name, and let me make sure that's what I named it here. Yep, I did name it first name. So first underscore name, like, and I can specify that I want them to start with a J, and then place an ampersand afterwards. Right, and now it's just matching string from the very beginning. Anything that starts with a J will get returned. So there you go. I get both John and Jane being returned as my two employees that have a first name that starts with a J. All right. Now, let's go ahead and take this into the next level, right? What if we want to match some sort of string, but it's not necessarily near the start or the end? It's just someplace within the string, right? Maybe I want to check if inside of my license plates, there is multiple license plates that have one specific letter, which as I'm looking through now, there doesn't seem to be much repetition with the exception for X, right? So I want to grab all the license plates that have an X within the, oh, hello, where did you go? There you go. Within the plate number. Well, I can say select all from plates. And I think that's what I named it. Let me make sure here. So it looks like it's only plate. And I can say where plate number like. I can say, hey, I just want to find anything that has an X in it. Well, to specify that it's anywhere in the string, I would put an ampersand on both sides. And then as long as it finds a capital X, it will bring that information back. I run my queries, and there we see that there's two license plate numbers that have the letter capital X within it. All right. Up to this point, does anyone have any questions about the like operator or how it works? Okay, if there aren't any questions, we're going to take this like operation to the next level, where we're going to make it where it doesn't care about capitalization. Right, so currently we have it where it does care about capitalization when I have that like statement. Right, if I run this like statement with a lowercase x, we're going to see that it returns no plates. But by running this I like statement, it's making it case insensitive, meaning it doesn't care about case. And it's able to compare with both uppercase and lowercase of the actual instance of the character X. All right. So there is our like statement. All right. Awesome. The next thing we're going to be covering is going to be your in statement. Let's say, the 4th of July just passed by. Maybe I want to grab any cars that match the color pattern of red, white, and blue, right? I'm going to go ahead and select all from car, where color, excuse me, is in, and then I can provide a series of options within this list. I can say it's red, white, or blue. And there's my statement. All right. Now we'll check my colors. When I run this, you can see that I have these cars where some of them are blue, red, or white. All right. To take this into a different approach, we don't only have to do this with strings, we could also do this with numbers. So let's say that we have, oh man, I'm trying to find a good example for numbers. I don't think with the current database that we have gives us a good example for numbers without touching IDs that are supposed to connecting us to something else. Oh, we could do the years. What's that? Let's do years for cars. All right, so let's say, hey, I want to grab specific cars that are in the year 2017, 2020, and 2022. Only those specific years. Well, I can, again, select all from car, where year is in 2017, 2020, and 2022. And when I run this query, we'll see that it also matches along with not only string, but with integers as well. And that is the in operator. Does anyone have any questions regarding the in statement? All right. Well, if no one has any questions, let's go ahead and move on into the as statement. So far, we've been doing this select all. You can grab specific fields and give them an as operator as well. So you can say, hey, I want to select, let's say, color, and I can specify as and say vehicle color from car. And by running this information, I would get back a table that at the top, instead of saying color, it states the alias that I've provided, a vehicle color, and it returns all of the colors within my table. All right. We talked about having the total sum of all services. So let's say select sum of price as complete service cost. Let's do 4 services. And excuse me, it's supposed to be a from services. Well, now when I run that, it gives me a more detailed explanation of this query where it says, hey, this is a complete service cost. If you want to get a complete service, it's going to cost you $129.97. That's all as it's doing. It's just essentially providing an alias for information. If I were grabbing multiple objects, so let's say I wasn't doing the sum, right? And I was just doing price as service cost. And let's say I was grabbing I'm assuming it's name. Let me make sure here. So we have name of service. So let's do name of service and separate it by a comma. Well, now when I run this, I get the name of service on the left-hand side and the service cost on the right-hand side. Now, something to keep in mind when you're utilizing the as operator is that if you provide an alias from the very start and then don't provide an alias for the second argument, it's still going to work correctly. And I apologize, everyone. I was pretty sure that would throw an error, but that's good to know that it works correctly as well. So it looks like there is no limitation or fault order. You can add an alias regardless whether it's the first or second argument, and you don't need to have a continuation there. All right. Does anyone have any questions regarding the as statement? All right, let's hear it, Brandon.
Are we able to use the as statement to change? Could you scroll up a little bit in the terminal?
Mm-hmm.
Up to the colors, I believe it was. No, one more. Keep going just a little bit further. Yeah. Are we able to use the as statement to change the driver column from the ID to like the name of the driver?
No, you can't do that. You would have to run a join query. We'll go into that here shortly.
Okay. Thank you.
Of course. All right. So now that we've gone over the like statement, we've gone over the as, let's go ahead and start talking about our limit statement, right? So sometimes you may want to run a query, but you don't want to grab all the information. So let's say that I just want to grab the first 3 entries that were ever placed into the database for today for vehicles coming in for service, right? Well, I can say select all from car, where, and excuse me, it would just be limit 3. I only want to grab the first 3 entries of the day, and we can see that the first 3 entries to be placed into the database was a Toyota Camry, a Ford Focus, and then a Honda Accord. All right, if I wanted to see these backwards or upside down where I could see the last entries, then I would go and place the descending order. Oh man, I always get these backwards. Let's see. It looks like I may need an order by statement. Yeah. There you go. So I need an order by statement, which I didn't mean to go into. Let's revisit this query later on, because I think I went a little too far, and we don't necessarily want that just yet. All right, so we talked about our limit. It does go into descending next, but we can't go into descending without speaking about ordering. So let me take off this limit here, and let me run this query right now. So currently the query brings us back all of our make and models, right? Well, I can order this by any field that I would like. I could order it by a field that's utilizing text, and it will compare it in an alphabetical order. Let's do model so that we can see the behavior of what happens when it's messing with both numbers, special characters, and characters in themselves. So let's do order by, and what I want to do is order by model. Well, when I run this query, we can see that the first thing that comes up are numbers. After that, it knocks into alphabetical order. When it comes into comparing special characters against alphabetic numbers, special characters come in priority as well. So special characters are first, and then letters, right? And we can see the rest of it is pretty alphabetical order standard. There you go. I can order by, and it's just essentially ordering it in ascending order, meaning A's come first, Z's come last, as expected, right? So that's how you can order something. If we had a timestamp as to when a car was checked in, and we wanted to do something where we grabbed the last 3 vehicles that were checked in, we would do order by the time of check-in, and then we could add a descending statement to flip our table upside down. Right? So there you go. Now, what I did earlier is I utilized the IDs, which you can also do. And it's not really going to change any of the behavior to order by ID. The only thing that this is allowing me to do is apply the descending statement. And that's how I can flip the table upside down from 10 to 1. And then I could say, well, I only want the last 3 entries in the database, so limit it to 3. And that's how we get the last 3 vehicles entered into the database. All right. Does anyone have any questions regarding order by, descending, or limit? Okay, so it doesn't look like there are any sort of questions. So the next thing that we're going to move into is our group by statement. So sometimes we'll run into some issues where I'm trying to maybe select the make of something, and I want to also grab how many instances of that make is in there, right? Well, you could think, well, maybe I could do count as make, and I can say that I want to grab this from car, right? Well, when I run this, I'm going to get a couple of errors here. And this is happening because I'm trying to utilize the count function. So if I'm trying to utilize the count function, it's automatically trying to group everything together because I didn't give it a group by statement. So make technically doesn't exist anymore. So in order to stop that from happening, I can still have it to say, hey, I want you to count everything. But rather than grouping my entire table of cars, I want you to group by make. And now when I run my query, it's grouping all the instances of a make. And you can see the count for each individual make and model that's being placed in there. Let me see if we have a different way to show this. Probably not that. Doesn't seem like we do. We could try years. So maybe I want to see all the cars or get a count of cars in a specific year. So all we would do is change this into a year statement. And then it would show me all the different cars that we have per year. All right, so in 2020, vehicles made in 2020, we only have one. We have 2 vehicles made in 2019, and so on from to 2020, 2019, and 2021. All right. Now you could chain these. All right. I can say, hey, I want you to grab this information from cars. I also want you to group by year. And I can say, I want you to order by year. And I want you to do this in descending order. All right. And there you go. We can still get 2022, 2021, and so on. I'm just chaining all of these different commands. I'm still grouping. I can still order. And if I want to, I could even still add a limit saying, hey, I just want the last 3 years or the highest 3 years. And just like that, we get 2020 to 2022. All right. Does anyone have any questions about our group by statements or order by statements? All right. Now we're going to talk about a little bit of something called categorization. And we're going to go into both of the examples that are here in our curriculum. Essentially, what we want to do is we want to create headers for each one of our fields here. But I can't just do it with the ask clause because it's going to be a conditional header. All right. So I'm going to say, hey, I want to select. And then I'm going to open up a case. And this case is going to say when the price is less than 30, then it should return, hey, this is a low price, all right? Now, if it's not less than 30, it will go into the next statement, at which point I'll check if the price is less than 50. Then it will go into my median price. And then finally, I'll give it an else, which is my final statement or my default statement. I'm going to say if neither of these get triggered, then we're going to call this high. And then I'm going to end as price range. All right. And I want this all to happen from the count of all. Let's do this first like this. Let's do it from services, which I believe that's what we had here. Let me make sure that's what we called it in the database. We did call it services. All right. From services. And I believe this should work as of right now. So let's go ahead and try to execute this command. All right, so it seems like it doesn't work. We have a syntax error. And that's happening here. All right, so there you go. We get all of our price range. All right, and it's all happening from services. And notice that the comparison is happening on the price field. Right, so it created a table named price range. But rather than returning the actual prices, it's returning, hey, is this low or is this medium? All right, if I pull up my services here and I pull them up side by side, Well, it goes into the first one. It says this one's $29.99. It's less than $30. This is a low. This one is $19.99. It's still less than $30. That is a low. And then it goes into $79.99. It is not less than 30. Goes into the next one. It is not less than 50. So it falls into our default statement of high. And it creates the high. So I'm creating a conditional statement as to what it should return in the table depending on a condition, right? Kind of looks like a switch case. All right. Well, this is just this first parameter of what I'm selecting. I can select something else. All right, so I can come over here and say, not only do I want my case or my price range, I can also select the service name. And so I can say name of service and have that all come in from services. So that we can see low, low, and high for the name of services. All right, let's do a quick recap here. This is all my very first row, or excuse me, my very first column, right? This case isn't in reference to what's going on in the header. It's in reference as to what each field is going to be turned into, rather than showing me the price of 29, 19, and 79. It's instead showing me a low, medium, or high for the cost of my services. This is all one argument of what I am selecting. My comma tells my select statement that there is a second field that I want to grab. That field is name of services or name of service. And I'm grabbing it from the services table. And that's how we end up with this table down below. Does anyone have any questions regarding our ability to utilize a case to create a field? This one's a complex one. I'm sure there's a question somewhere. No? Everyone has it? All right, moving forward then. If we are good with cases, then it's time that we start talking about some join tables. So when it comes to joins, there's three types of joins. There is a full join, a left join, and a right join. So I'm just going to go ahead and provide us this small visual. I'm going to draw these in two separate tables, right? So here we go. And actually, you know what? It might be better if I copy and paste this. All right, so here's our two tables. At some point, they overlap with a field of ID. So likely here, we would have something that says, hey, this is my primary key of ID, and it would be a series of numbers, all right? Oh, wow, I am bad at this. Well, on my opposite field, I may have a connection to said table, but this connection may be something titled X underscore ID. Right, and this could also be a series of numbers. Maybe it's 2, 3, 4, 5, and then 1 at the very end. Well, how do these two connect to each other? Right, when we run a query, the most common query that you'll run when it comes to join tables will be the full join. And what the full join looks like, it's quite literally what it sounds like. It sounds, let me just group these together here real quick so that I'm not running into any issues. where we are joining both the left and right-hand sides of the table. And what we'll return is the entirety of both tables. So there we have a full join. Right, we're getting both the left and right-hand side. All right. So with that said, a left join would return the entire left-hand table, but it would only return a specific field of the right-hand table. So let's say we wanted to grab name. Oh, turn that into a yellow character there. From this table as well. Well, what we would do is we would actually bring it in like this. But the only additional mark that we would have would be that end string for table. All right, so, oh my, I've made a mess of this. I apologize, everybody. All right, there you go. That makes more sense. So now if I were to grab it this way and I just wanted the first and last, or excuse me, I just wanted the name, it would fall as such within my table. Right? It is a left join because I am still grabbing the majority of the left table. So this is a left join. I'm only grabbing a particular field of information from the right table. Go ahead, Momo.
Yeah, how the SQL know this table left or this table right? How it know the direction of the tables?
The first table that's mentioned will be the left table, and the second table that is mentioned that we're joining to will be the right table.
Okay, so always the first table is the left table.
Say again?
So that means always the first table will be the left table.
That's correct. Yes.
Okay, thank you.
Of course. All right. And then if we were to run a right join, well, we would get the same thing, but vice versa, right? Where a right join would have majority or all of our right-hand side table. But it would only have this field here. And maybe in this case, what we're trying to grab is not a name, but instead a serial number or somewhere along those lines, right? So let's go ahead and say a serial number. And that's what would fall from our left join. I'll clean up these drawings before putting them in demos and notes today, I promise. So there's our right join, right? So a full join gives us both tables. Left join gives me all of my left table, but only specific fields from the right table. And then my right join gives me all of my right table, but only specific fields from the left table. Does anyone have any questions regarding this concept before we start drawing it out in code? Momo?
So by the same mean, the right joint, the second table would be the right table, right?
Right. The second table would be the right table.
Okay, thank you.
All right. Moving forward here. Now that we've seen it in drawing, well, let's see it in code. All right, we have a couple of connections that we can talk about. And for now, I'm just going to concentrate in my driver and my cars table. All right, well, if I take a look at both of these, I can see that my driver, we can see that my driver currently doesn't have any connection whatsoever to my cars, but my cars does. So how do I do this connection, right? Starting off with a full join. I'm going to go into queries and I'm going to do a full join between my car and my car. Oh, excuse me, my car and my driver. Excuse me, I'm trying to find the correct portion. All right, here we go. So what I want to do is I want to select all, and I'm going to specify here. I'm going to say car.all, and I want driver.all. And I want this from. Now, here is where I'm specifying my left table, which is car. And I want this table to join the driver table on where the car dot driver, and let's take a look at car. Car dot driver is a series of integer. Well, I want to do this where it matches the driver dot ID. And if I take a look at driver, ID is a series of integers, right? So think about this as if we had two lists of objects, right? So here we have our cars, and at some point in this car, we have an object that says driver, and it has the ID of 1. And think about the driver as a list of objects as well. But in this case, we have an ID with the ID of 1. All right, well, what we're utilizing here is we're saying that I want to iterate through both of these. So I want to work through both of these lists. And please excuse my my bad Python here. So I'm going to say 4x in cars. And from there, I'm going to say 4j, or let's go with I in driver. So there's my two loops in there. And what I'm going to say is if, or I'm going to just return here, return if x dot driver is equal to I dot ID. That's all I'm doing in this table. All right, I'm iterating through cars and I'm matching them with it to join within the driver class. Right, this isn't what's actually happening under the hood. Under the hood, it's a lot more efficient inside of PostgreSQL. That's the whole reason why we use relational database management systems, is because they have a better way of managing this connection than this Python code. I'm strictly just writing this Python code to give us a relatable visual as to what behavior we're trying to mimic here. Right. So now let's try to take a look at what happens when I run this query. Well, when I run this query, we see that we get a massive amount of information here. I may have to minimize this here. There we go. Oh, I broke it. There you go. So we can see I get a massive amount of information, right? It is a full join. I am getting all of my left table, and I am also getting all of my right table, right? It is matching all of it. I am getting a full join table. All right. Does anyone have any questions about conducting a full join? Okay. Now, we could also give these things aliases, which is something that's very common. Some people just do it where they do it this way, right? You leave a space, and then the following thing after that blank space will be the alias. So now anywhere where car is mentioned, I can change that for C. And anywhere where driver is mentioned, I can change that for a D. And this query will still work exactly the same. All right, so I just executed my query SQL one more time, and we can see that it still returned the same exact table. Now, nothing changes. We can still do our group by statements, and we can do our where statements and order by, right? So maybe in this case, I want to run some logic where I order by, I don't know, maybe the age of the driver. So let's say order by driver.age. And I also want it in descending order so that we can see it upside down. Well, now when I run my query, we can see that I'm getting back all of my cars and driver information, but it's all ordered by the age of my driver from oldest to youngest. All right, I'm going to go ahead and pause there and open up for questions. Does anyone have any questions regarding the full join table? Okay, no questions regarding the full join table. So let's go ahead and move on to my left join. So in my left join, I'm still going to keep this join here. I'm actually going to copy and paste it so that we don't lose any information here. All right, so I'm still going to keep everything here as far as what I'm actually doing. But when I go to this join statement, the only thing I'm going to change syntactically is I'm going to specify, hey, this is a left join. I only want you to grab everything from the first table, or everything, whether I need it or not. So if I'm asking for it or not, I want you to grab all of the fields to run the following logic. Now, on my right-hand side, it's only going to grab exactly what it needs. So if I were to say, rather than grab everything, well, I want you to grab the name and the age, right? And I'm actually going to take off this order by and descending statement because I believe it's going to have some weird behavior. Well, now when I run this information, we can see that it only brings back up to the driver. Notice it didn't show me my driver ID anymore. That's no longer part of my table, right? It's showing me the name and age. Now, this is great. If I were to take off this left and do a full join, what would be the behavior? It still returns the same exact information. So why is it important to specify that I want a left join or a full join if I'm still getting the same behavior? Well, let's try to run an explain method here. I'm going to go ahead and add that explain analyze. So I'm going to add those keywords there and run it. All right, well, here we have a left join. It looks like it took a planning time of 338 and 90 seconds to execute. All right, we can take a look at the cost here and look at the memory usage, right? And there's some buckets, some batches. It's telling me, hey, it took 9 kilobytes to be able to do this. Okay, and we can see that there's multiple sequentials happening at the same time. Well, let's turn this back into a full join. Let's see what our answer is when I run it in a full join. Well, here's the planning time for a left join. It took a little bit extra, right? And here's the execution time for the left join. It still only took 90 milliseconds. Here's the planning time for a full join. And here's the execution time. Now, this is a little bit misleading because this looks like the full join was more effective. That is not the case, right? And whenever you're working with a considerable amount of data, the reason why you want to specify the left or right join is for performance, right? If I don't need all that information, there's no reason to ask for it, right? We'll see that later on in the sequentials. And once you're working with more sophisticated data, this will become more obvious. You need to make sure that you're specifying only what you need. If you're not running logic that requires information from the right table, then only run a left join. Does anyone have any questions regarding left joins? Momo, I see you put something on the chat. Is that in reference to a question that you have here, or was
No,
that
I
just
just
a...
was trying to answer the Dustin question when he was asking about to specific period of time, like
Oh,
from now and 5 years ago.
oh, awesome. Thank you. All right. So now that we've covered our left join, well, let's try to break our left join, right? Let's say that rather than asking for age, all I'm asking for is the name. Right? And I try to run this information. Okay, great. Well, what happens if I put an order by statement and I try to say that I want to do this depending on the driver's age? Well, let's try to run that. So everything works. It's just not showing me the information. Again, it's going to analyze what's happening under the, it's only going to grab the table and only grab the attributes that it needs to execute the function out of the right table. All right. Same thing can be said for right joins. If I were to run a right join and the only thing that I'm grabbing out of my my car is my make and my model, and let's go ahead and do year as well. And I want to grab everything regarding the client. Well, this would be a right join from car. Here's my car or the driver. And I'm going to join where the C driver is equal to the DID. And there you can see we get the make, model, and year for the entire vehicle. And then we have our 10 customers as well, where they are matching and joining one another. So there is our right join and left join examples. Now, notice here in my right join, I have more drivers than it looks like I have vehicles, right? So let's go into cars and take a look at that. So as you can see in cars here, we have 1 and 1. You can see that the instance is being duplicated, right? Now, when I ran this right join, Linda Turner doesn't have a vehicle, but Linda Turner was still returned, right? Because I grabbed everything from the right-hand side, and it just gave me a blank space on the left side. Well, let's try running a left join so we could see a difference there. Well, when I run a left join, you'll see that all of the matching vehicles were returned, but Linda is no longer showing up in my table. Well, that's because I'm grabbing strictly from my left table, meaning that if something in my left table doesn't have a match to the right-hand side, it's just not going to grab it. Whereas when I had a right join, I was grabbing strictly from my right table. Meaning that whether it has a match or not, it's still going to return that information, but just show me that it has no match. All right. And that is our joins. Does anyone have any questions regarding full join, left join, or right join? All right, I know we're going a little bit long in the lecture, but the last thing that I want to show us is how to handle a many-to-many relationship. So we have our many-to-many relationship, but we look at our draw SQL here. Our many-to-many relationship is happening between services, car service, and car. So let's say we want to grab all that information, all right? So here is my cars. I want to grab services, and I also want to grab car services. And I may actually just bring my TL draw here. Since I copied it strictly from the fields, I should be able to just use this to reference what I need. Let me open it up here a little bit. There we go. That will give me some extra room. All right. So let's go into our query here. Well, I want to grab all of the cars and their specific services that are happening. All right. So I want to say, hey, I want to select from C. This is going to be my car. And what I want to select from this car is the make, the model, and year. And then I want to select the name of service. So S will be the name of service or the services, and I'll grab name of service as service. And then finally, I'll grab price. All right, so there's all the information that I want, right? I want my car's make, model, and year, the name of the service that it's receiving, and the price. Okay, well, let's start this off, right? Where is this connection actually happening? Well, this connection is happening at the car services. So I'm going to say from car service. And let me ensure that that is what, in fact, we call the database. So we did call the car service for the table. And I'm just going to give this an alias of X. And what I'm going to do is I'm going to join X excuse me, I'm going to join this with services. I'm going to give it an alias of S on where X dot service ID is equal to S dot ID. All right, so that's going to join my first set of tables. It's joining my services to my service ID. All right, great. But I also wanted to join where with car, and I want this to join on where X car ID is equal to C dot ID. All right, so there's my whole query. Let's see what it looks like. All right, so when I run it, my query is executed. I have my many-to-many relationship there. I can see them all being compiled. And I can group them by the car if I would like it to, so I could see the different services. But I can see that I have my Toyota Camry for an oil change, a Ford Focus for a brake inspection, the Honda Accord, and we see the Honda Accord is also in there for a brake inspection, not only the engine tune-up. We could see some repetitiveness on my many-to-many relationship, and I can see all of those prices. All right. Does anyone have any questions over how to run a join query on a many-to-many relationship? Okay, great. If no one has any questions, I'm sure we're all burnt out from seeing SQL queries. I'm gonna go ahead and